Hey everyone, thanks for joining today's webinar on optimizing visual analysis on construction projects using Cintoo Cloud. My name is Nicholas Zarnick, and I'm a Customer Success Manager here at Cintoo. I work closely with many of our architecture, engineering, and construction industry clients, and today I'll be sharing some tips, tricks, and best practices for using visual analysis tools in Cintoo Cloud. Agenda items for today: I'll be covering each of these topics with a mix of walkthrough videos and summary slides. We'll start with our BIM 360 interoperability and how to work with model files from your BIM 360 projects in Cintoo. We'll talk about our alignment tools and comparison tools and typical workflows for issue tracking. Then I'll touch on comparing scan versions for scan versus scan analysis and leave some time at the end for Q&A. So we'll start off with some tips and best practices for importing models from BIM 360 to Cintoo and working with scans and models in 3D view. We have the Cintoo project open in our Chrome browser, and we can see scans and model data visible in the 3D view. The sample scan and model dataset was provided to us courtesy of SSOE Group. When working with scans and models, it's always a best practice to use work zones to organize and structure your Cintoo projects. For optimal control and performance, it's best to keep models and scans in separate work zones. So for this project, we have specific work zones for each dataset. If we switch over to the Data tab, we can see that there's a specific work zone for our federated Navisworks model. There's a parent work zone for our Revit files, which has been divided into sub-work zones with a discipline model in each. And we also have a parent work zone for our scans, which is also broken down into sub-work zones by areas of the project and also by levels of the project. For model files, we typically recommend sticking to one model file per work zone. This gives you the most flexibility when loading data in the 3D view. With one model file per work zone, you're able to load and toggle each model directly from the Project Explorer. And for these Revit files, since we have a parent work zone that contains all the individual discipline subwork zones, we can load all discipline models just by clicking the parent work zone. We can also use the same process to load our scans in the 3D view. Clicking the GIM Level 1 work zone will only load the scans in that specific work zone. And we can toggle on other work zones to add scans to the view. Clicking the parent scans work zone will load and display all 471 scans in this project. So the best practice for organizing scans is to limit each work zone to no more than 100 scans each. And the recommended workflow for viewing and navigating scans and models in the 3D view is to load your scan data first, then toggle on model files as needed. Since all the model files in this project were imported using our Autodesk BIM 360 integration, I'll switch over to our BIM 360 project and share some tips about the Cintoo model import process. In document management, under our project files, we have each individual discipline Revit model that was imported to Cintoo individually, as well as the overall federated Navisworks model. For Revit files specifically, when there's multiple 3D views published to the cloud model, by default, BIM 360 will always display the oldest view first when opening the file, and this is the view that gets pushed to Cintoo during the model import process. In this case, even though the for Navisworks view appears first in the list, we can close out of the model and reopen the file, see that this view displays by default each time. And if we switch back to our Cintoo project and toggle on the exterior facade Revit model, we can see that the same model elements have been imported to the project. So for now, the best way to control what geometry gets imported to Cintoo is to ensure that the oldest published view contains the desired model elements. Another tip for importing model data to Cintoo is to use the model update feature to sync changes in the model files directly to the Cintoo project. When importing models from BIM360, Cintoo will automatically read the version number of each file. So if we switch back over to Cintoo and look at the files in the Data tab, we can see the version number displayed for each file. You can verify if the file is up to date by clicking the Check for Updates button. If it's the most current version, it'll show no updates are available. And if there's a more recent version of the file in BIM360, you can click the Update button to automatically sync any changes to the file in Cintoo. You'll get an email notification when the file is finished updating in Cintoo, and clicking the link will open the project in Cintoo and show the updated version number for that file. And one more tip for working with models and scans in Cintoo, especially large or heavy model files, is to use crop views to maintain performance in the web browser. To do this, open scans for a particular level or area of the project in the 3D view. First, make sure you have the Turbo Mesh setting enabled to see the highest resolution mesh surfaces in the 3D navigation mode. Next, open the crop tool and adjust each face of the crop box, either by pushing and pulling the planes, or by switching to an ortho view mode and using the axis sliders on the right of the screen. In order for this to work properly, you need to adjust all planes of the crop box. So be sure to modify the top, sides, and the bottom planes. And you can switch between ortho mode and perspective mode to make finer tune adjustments. And when you have everything set the way you want, click the Add button to save the view to the crop list. We can rename the view to something more specific, like Scope A1, and then exit out of the crop tool. Now, when you toggle on the models, it will only display the model elements within the crop view, which should maintain performance and reduce lag in the web browser. You can think of this like using scope boxes in Revit. So if we go back into the crop tool to reset our view now, and toggle the models back on in the Project Explorer, instead of loading all of this unneeded data and extra model geometry in the view, using crop views gives you the control to only load what's relevant to the area of interest that you're working in. And using this technique should maintain optimal performance as you navigate in 3D mode and in scan mode as well. As a recap, here are some best practices for working with models in Cintoo. Break up large data sets when feasible, and import the individual models separately for optimal control and flexibility. It's always best to keep scans and models in separate work zones. This is also essential for using the alignment and comparison tools. When it comes to organizing your Cintoo projects, try to keep your model work zones limited to one model file per work zone, and for scan work zones, 100 scans maximum per work zone. And using the Cintoo crop views is a good way to optimize performance in your web browser and to avoid loading unnecessary model elements in the 3D view. In this next example, we'll cover some recommended workflows for using the alignment tool in Cintoo with scan and model data. Here I'll share some alignment tool best practices. We have our Cintoo project open in 3D navigation mode, and we want to make sure the turbo mesh setting is enabled. We also need to make sure that both our model files and our scan files are toggled on and visible in the 3D view. When opening the alignment tool, it's always best practice to verify the units first. You can switch between feet and meters here. In the selection fields, we can assign all scans in the to align field and all models as reference. Moving the visibility slider will adjust the opacity and transparency of each dataset in the 3D view. With all scans in the align field, we can automatically center scans to models by clicking the Move Center to Center button. We can also switch around the selection fields and center the models to scans as well. Typically, it's best practice to align scans to models in your Cintoo projects. In the translation fields, you can enter values to move the data in the X, Y, and Z directions. You can also hover the cursor over each value and use the mouse scroll wheel to increase or decrease the distance values. A tip here is to use the Control, Alt, or Shift key while scrolling with the mouse wheel to modify the increments of movement. Holding the Control key will move the data in larger increments, and you can fine-tune the alignment with the Alt and Shift keys. And it's important to note that these transforms will be retained in the scan data, while model files lose the transforms if updated or re-imported to the project, which is why it's always best practice to align scans to models. To apply rotation, set the pivot point by clicking the location on the data. You can move the sliders to adjust the rotation in the X, Y, or Z axis. You can enter rotation values in degrees for each axis. And you can use the mouse scroll wheel as well to adjust in increments. Using the view tiles and switching to ortho view mode is another helpful way to get a better look at the alignment of the datasets. Use the top-down view for adjustments in the X and Y directions, and the left, front, or right views for moves in the Z up axis. Before clicking Apply to save the alignment, it's always important to record any translation and rotation values used, and to utilize the different navigation modes in Cintoo to verify the alignment. We can switch the view from 3D navigation to scan mode to help verify the alignment from an interior view as well. All features of the alignment tool will work the same in scan mode, so translation, visibility, and rotation adjustments can still be made. And color overrides can also be applied to each dataset to easily distinguish scan elements from model elements. Here we're seeing all as-built data captured in the scans in blue and all design model geometry highlighted in pink. And we can easily reset the color overrides from within the alignment tool as well. And with the Turbo Mesh feature enabled, we can switch back to 3D navigation mode while keeping the highest resolution mesh surfaces visible in the view. And when you verify the alignment and everything looks good in the 3D view, make sure to click the Apply button to save it to the project. Be sure to clear out the selection fields before closing the alignment tool. If you notice the scan sprite icons are highlighted in pink, it means the data sets are still assigned in the alignment tool. And as a last check, it's always important to verify that all model files remain static during the alignment process. In this next example, we'll troubleshoot a common issue we see when models and scans in Cintoo contain different coordinate systems. If models and scans are toggled on in the Project Explorer, but when opening the 3D view, there's no data visible, the first thing to try is to recenter the camera. If the view remains empty, we typically recommend isolating each dataset and recentering the camera on each. Here we can recenter on the scans when the model is toggled off, but the datasets cannot be displayed together in the view. Since the scans and model are located very far apart from each other, this results in extremely large view extents in the 3D view. And the usual sign of this issue is visible glitches when viewing the model or scan data. So the recommended workflow here is to isolate and focus in on the model, and then use the alignment tool to automatically center the scans to the model data. And with the data much closer together, it'll be much easier to make the necessary translation and rotation adjustments. So here we're using the mouse scroll wheel along with Control, Alt, and Shift keys to make incremental movements and adjustments to the data in the X, Y, and Z directions. So once the data is aligned properly and you're satisfied with the results of the alignment, click the Apply button to save the alignment to the project, and be sure to clear out the selection fields before closing the alignment tool. In some instances, the visible glitches may still occur after alignment. Here we're still seeing the issue when viewing the scans and model together in the 3D view. So if you still notice visible glitches on the data after alignment, refreshing the browser window typically resolves this issue. Some alignment best practices include making sure scans and models share a common origin point and orientation prior to uploading the data to Cintoo whenever possible. Doing this setup and coordination before importing the data can save you time and effort by minimizing the amount of manual alignment you have to do in Cintoo. Always align scans to model data when using the alignment tool. If you translate or rotate models to align with scans, you'll have to repeat this step each time the model file is updated or re-imported to the Cintoo project. And using the mouse scroll wheel, together with the Control, Alt, and Shift keys, will give you the most control to make fine-tune adjustments with the alignment tool. Next, we'll share some tips and tricks when comparing scans and models in Cintoo with the comparison tools. Here we have models and scans open in our 3D view, and I can switch from 3D navigation mode into scan mode to open the nearest scan position. So with scans and models visible in our 3D view, we can open the comparison tools to compare scans and models. First thing to always verify is the unit of measure. Here we can switch between feet and meters. In the selection field, we can select all scans to compare and select all models as reference. When we turn on the visual difference tool, it'll automatically generate a colored heat map in the 3D view. For flat shading display mode, the color heat map will show items either within or outside of this tolerance range that we can adjust with this distance adjustment slider. So any items highlighted in red are items outside of this tolerance range, while any items highlighted in green with this flat shading mode are items within the tolerance range. In addition to adjusting the distance with the slider, we can also use our mouse and scroll wheel to modify the increments, and we can type in specific values. So here we're viewing the flat shading comparison tool with a tolerance range of about 3 inches. Toggling on the visual check tool gives us the ability to adjust the opacity and transparency of each dataset. So moving the slider to the left, I can isolate just the scan data and hide the model data. As I move the slider to the right, I can isolate just the model data and hide our scans. We toggle the visual difference tool back on and switch from flat shading to soft shading mode. This will give us a wider color gradient representing the position of objects relative to our camera view. So for instance, this piece of wall-mounted equipment is something that was captured in the existing scan data, but is not shown in the design model. So in the soft shading mode, this element in the scan data is in front of the design model, which highlights that element in red. If you look at these ceiling mounting equipment, for example, we can see that these are fixtures in the design model that are not captured in the existing scans. So switching back to the visual difference tool, these elements are highlighted in blue because the scan data is behind the model data. So using the soft shading mode is good for more in-depth analysis, and using the flat shading mode is good for quickly identifying potential issues. So for instance, we have this red area here in the view. If we switch to our visual check tool, we can see that there's an existing wall in the scan data that's missing in the design model. Over along this wall here, we can see that there's some detail items captured in the scan data that has not been added to the design model yet. And further up in this area, we can see that there's this long half wall that's been captured in the scan data, but is also missing in the design model. So now that we've identified some potential issues, we can mark these with the Cintoo annotation tools. Here, I'll open the annotation tool and click Add Annotation. You can click on the element highlighted in red and assign this annotation as an issue. We'll title this Add Wall, add the label as Modeling. We can set a severity level. We can set a due date for this issue, and we can assign it to another project member. When we click Create Annotation, it'll save that issue into our view and to our annotation list. So I can repeat the process for the other two areas. For the area along this wall, I can click Add Annotation, make this an issue. I'll call this one Add Details. Label is also Modeling. Severity level, due date, and assign. And for the other issue, I'll look at this half wall here. Click Add Annotation. Assign this as an issue. Call this Add Half Wall. This one's also Modeling. Severity level, due date, and assign to. Now that we have these markups and annotations saved to our annotation list, we can use our Report tab as part of our issue tracking workflow. Some quick notes on best practices for using comparison tools. It's always better to use scans as the primary data set for your comparisons, since the as-built existing conditions captured in the scan data contains more 3D elements and information than model files. Make sure to use exact tolerance ranges by typing in values for the distance adjustment setting. And it's always good to use flat and soft shading in tandem. Flat shading for quickly identifying potential issues, and soft shading for more in-depth analysis. Next up, we'll talk about issue tracking workflows in Cintoo Cloud. Here we have the list of issues created with the Cintoo annotation tool displayed in our Report tab. We can filter the list by name, by labels, users, or activities. Each issue contains a Play 3D link that we can click to open the issue in 3D View tab. Back in the Report tab, we can also export the list of issues as a PDF file. And if we open the PDF report, we can see that each issue is live linked back to the Cintoo project, where we can select the specific issue thumbnail and open that issue directly back into the Cintoo project. From the Report tab, we can also export our Cintoo issues as BIM collaboration format files to import into our design authoring software. And in terms of integrations, we have our Cintoo project linked to a BIM360 project and a BIMtrack project, where we can automatically sync and push our Cintoo issues directly into these cloud platforms. When the issues are done syncing, we can click the associated integration link on each issue to view in those platforms. So I can open this BIMtrack link and see the Cintoo issue directly within the BIMtrack platform. I can also click on the Autodesk BIM360 logo to view the issue in our BIM360 project. To resolve these modeling issues in Revit, we can switch to our 3D View tab and create crop views of our scan data at each issue area, which we've already done here. And with crops of our scan data saved to our crop list, we can export each view as a recap format point cloud to link into our Revit model. Switching over to Revit, we can use the BIM Collab add-in to import the BCF file we generated from the Cintoo Report tab. So clicking the BCF zip file, we can open the file, and the BCF file contains the camera view and position for each Cintoo issue. So you can open the issue at the exact view in the Revit model. From here, you can link in the corresponding point cloud files to carry out the modeling work. So here we've already linked in the 3 point cloud files that we exported out of Cintoo directly into the Revit model. And we can also use the BIMtrack add-in for Revit to carry out a similar workflow. With the point cloud files from Cintoo already linked in this Revit file, we can use the BIMtrack add-in to view and open the issues synced from Cintoo directly in the Revit 3D view. Similar to BIM Collab, each BIMtrack issue retains the camera view and position from Cintoo, which helps speed up the modeling process. And once modeling is complete, the next step is to publish the Revit model with updates to BIM360. So here we've published the updated Revit model to BIM360, shown here as model version 2. And if we switch back over to our Cintoo project, we can use the check for updates feature to automatically sync in those changes to the existing file in the Cintoo project. Once the updates have been synced, we can see the model version has changed to version 2. And the last step is to verify that each issue has been resolved in the model. So switching to the Report tab, we can open each issue in the 3D view and verify that the issues have been resolved. So for this issue here, add details, we can see that the details have been added on this wall, so we can mark this as resolved. We can go to our annotations list and click on the other issues. for this half wall, we can switch to our visual check tool and see that the half wall has been added in our model. So we can mark this one as resolved. And then for the last issue, we can check this issue here and verify that the wall has been added in the Revit model. Some best practices for issue tracking in Cintoo. Using labels helps you organize and filter notes and issues in the Report tab. Exporting crop views as point clouds keeps the overall file size light, which makes them easy to work with in Revit. And use BCF exports with BIM Collab or the BIM track add-in for Revit to expedite issue resolution during the modeling process. And for this last example, we'll dive into workflows for running scan versus scan comparisons in your Cintoo projects. In this sample project, we have two data sets, one with terrestrial scans and one with VLX scans. And especially for scan-to-scan comparisons, it's important to keep the work zone names specific and add the scan dates to the front of the work zone names to keep them in order in the Project Explorer. We can open our terrestrial scans in the 3D view to get a better look at the data. Here we can see the terrestrial scans done of this office floor. And if we load in our VLX scans, we can see pretty quickly that it's a scan data set of the same exact space. So with our VLX data set open in the 3D view, we can toggle on the terrestrial scans and see that the two data sets have already been aligned closely together. So we can enter scan mode of our VLX scans to get a better view of the interior. Here I can switch to a 3D surface mode. Then we can toggle on our terrestrial scans and launch our comparison tool. For this scan-to-scan comparison, we'll be using imperial units. We can select our VLX scans in the To Compare field and select the terrestrial laser scans for reference. And toggling on the visual difference tool, we'll use a 1-inch tolerance range for this comparison. We can do a quick visual check and see what exactly is in our VLX scan dataset versus what's in our terrestrial scan dataset. Toggling the visual difference tool back on, we can navigate through the data and see what's changed. So we can see in the stage area, there's a few podiums that are highlighted in red. If we switch back over to our visual check tool, we can see that there's a podium in the terrestrial scans that was either moved or shifted between the different scan sessions. There's also podiums here on this side of the stage in the VLX scans that were either moved or shifted between the scan sessions. Here to the left, there's more equipment here highlighted in red. It looks like it's the same piece of equipment that just may have been moved from one scan session to the next. This is a good opportunity to use color overrides. Well, we could use the visibility slider to get an idea of which element belongs to which data set. We can use color overrides to quickly colorize each data set and get a better idea of which element belongs to which data with both data sets visible in the view. So we have our VLX scans highlighted in this blue color, and we have the terrestrial scans highlighted in pink. Now this is just one quick example of comparing scan data sets but we can already get a sense of how useful scan-to-scan comparisons are for understanding how existing conditions in a space can change over time. And a couple best practices for scan-to-scan comparisons to wrap up this presentation. Use clear and specific naming conventions for the work zones containing the different scan datasets, and utilize the color overrides in the visual check tool to quickly identify which elements belong to which scan versions.